Welcome to Math 9 class with Mom MC, Mom Forts, and Sir Reynold. One of the things you will be learning today will be the triangle angle bisector theorem. What is triangle angle bisector theorem? So triangle angle bisector theorem states that if a segment bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. Now let us have this illustration. We have here angle TIY or triangle TIY rather. Now your triangle angle bisector theorem states that if, in this case, IZ bisects angle TIY, so this is your segment IZ and this is your angle TIY. Now, these two here are the tick marks. This is to denote that these two angles, your angle 1 and angle 2, are congruent. So that means to say this IZ bisected TIY or your angle TIY. Remember, once we say an angle bisector, it is a segment that divides an angle into two congruent angles. So in this case, the two congruent angles are angle 1 and angle 2. Now, if IZ bisects angle TIY, then ZT divided by ZY, or the ratio between ZT and ZY, will be equal to TI over TY, or YI rather, or the ratio between TI and YI. Now, ZT here is one of the segments formed after this angle bisector bisected or meet the opposite side of your angle TIY. ZT or ZY rather is another segment formed after your IZ and your TY intersected. Now TI here on the other hand is one of the two other sides of your triangle and also YI. So again, triangle angle bisector theorem states that if a segment bisects an angle of a triangle, then it divides the opposite side into segments, and our segments will be ZT and ZY in this case, and that is proportional to the other two sides, which are your TI and your YI. Now let us have an example. Solve for the unknown side applying the triangle angle bisector theorem. Now, this is your given triangle. Using these two tick marks here, this is to denote that this angle is equal to this angle or congruent to this angle. So therefore, this is the angle bisector. This is the angle bisector of our triangle. Now, this 25 here is the measurement of the first segment formed after your angle bisector meet the opposite side of your given angle. And this one is another segment, and that would be 40 minus 25 because this whole opposite side here is 40, and of course since the other segment is 25, then the other segment or the other segment will be 40 minus 25, and that is actually equal to 15. Now we are to solve for the unknown side. The unknown side is side S. Now this is the solution. So applying the triangle angle bisector theorem, we have here 25 divided by 40 minus 25. Remember, 25 here is the measurement of the first segment, and then 40 minus 25 here is the second segment. Now, these two segments here is proportional to the other two sides of our triangle. So the ratio of the other two sides will be, we have here S divided by 18. So S is in the numerator since they are on the same side as the 25, and 25 is the numerator on the left side of the equation. And then 18 will be on the denominator since it is on the same side as the other segment here sa aton nga equation. Now, 25 divided by 40 minus 25 is equal to S divided by 18. This is our proportion. So we need to prove that, or we need to look for the value of S here by using the techniques in ratio and proportion. So 40 minus 25 is 15. So we will have 25 divided by 15. That is equal to S divided by 18. We are going to cross multiply. Cross multiplication means you need to multiply 25 by 18 and then 15 by S, or 18 by S rather. 25 times 18 is equal to 15 times S. 18 times 25 is equal to 450. 15 times S, that is 15S. Now, we can interchange this two. We can put 15S on the left side and 450 on the right side. That is symmetric property of equality. 15s now is equal to 450. In order for us to get the value of s, it's either we multiply the left side and the right side of the equation by the reciprocal of 15 to get rid of 15 here, so that is 1 over 15, or we can simply divide both sides of the equation by 15. So either way, we will have s on the left side because 15 will be cancelled out, and then 450 divided by 15, that is equal to 30. So s is equal to 30. So the value of our unknown side here is equal to 30 using the triangle angle bisector theorem. Next one, we will be learning, or you will be learning, another theorem on similarity of triangles, and this is your triangle proportionality theorem. So what is triangle proportionality theorem? Triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So let us have this illustration. We have here your triangle TIE, and we have here segment WC, and as you may notice by this tick marks here, WC is parallel to TE, which is the third side of the triangle. And as your WC intersected both the remaining two sides of our triangle, it formed another angle or triangle, a smaller version of the original triangle. And you can also say that perhaps these two triangles are similar. But for your triangle proportionality theorem, given this case or given this illustration, if WC is parallel to TE, if this segment is parallel to this segment, then IW divided by IT is equal to IC divided by IE. So this is our proportion. Remember, IW here is part of the smaller triangle. IT here is part of the bigger triangle. IC is part of the smaller triangle, and IE here is part of the bigger triangle. So if these two are parallel, then we can say that the parts of our two triangles will form proportion. And remember, if this IW here divided by IT here will be equal to IC divided by IE, that means to say they are proportion. Okay? And if they are proportion, now knowing that this included side, remember this is angle I. This is part of our smaller triangle, and this is also part of our bigger triangle. And this angle I is congruent to angle I. Okay? By reflective or reflexive property. So that means to say these two triangles are indeed similar to each other by SAS. So we will be using IW and then IC and then of course the angle here. So the included angles of the two triangles will be congruent and their two sides are proportional. So therefore, by SAS, these two triangles here can be similar. Now let's go back to triangle proportionality theorem. Let us have some example. Let us have an example. Solve for the unknown sides in the figure. So we have here our given triangle. This is the bigger triangle. And then this is the smaller triangle formed by intersecting or by having a segment intersecting the two sides of our triangle and is parallel to our third side. Now, using the triangle proportionality theorem just a while ago, we will be solving for the values of R and S. We have here the unknown sides of our figure. Now, here are the solutions. Now, let us solve for R first. So, this is our R. R is one side of our smaller triangle. Now, R divided by 20 is equal to 15 minus 6 divided by 15. Now, R here is part of the smaller triangle. 20 here is a part of our bigger triangle. So, the ratio of these two should be equal to the ratio of the segments here on the other side. And those segments will be, okay, so this side here is part of the smaller triangle. And this measures 15 minus 6 because this whole side here is 15. And then here, this is 6. So that means to say this is 15 minus 6. So that is why we have here 15 minus 6 divided by the measurement of the one side of our bigger triangle. So that is 15. So r divided by 20 will be equal or shall be equal to 15 minus 6 divided by 15. So this is our proportion. We will be solving for the value of r. Now, let us first simplify this one. 15 minus 6 is equal to 9. So our proportion now is r divided by 20 equals 9 divided by 15. Using again cross multiplication, r will be multiplied to 15, 9 will be multiplied to 20. So 15 times r will be equal to 20 times 9. 15 times r is 15r, 20 times 9, that is 180. So 15r is equal to 180. Now, to solve for the value of r, we need to divide both sides of the equation by 15 or multiply both sides of the equation by the reciprocal of 15, and that is 1 over 15. Now, either way, you will have r equals 12. So, if you divide this one or this side by 15, that will be r. And then if you divide 180 by 15, that is equal to 12. So r is equal to 12. That means to say this side here of our smaller triangle is equal to 12. Now, we will be solving for the value of s. The value of s is this one, or this is the s. Now, how do we get for the value of s? Or how do we solve for the value of s? Now, this one is r, and that is equal to 12. This whole side here is equal to 20. So, if we are going to subtract 20 by the measurement of r, we can get the value of s. So, 20 minus r is equal to 20 minus 12 because r is equal to 12. So s then is equal to 8 because 20 minus 12 is equal to 8. So the given side here, or the unknown side here, which is s, is equal to 8. So this is 12, this is 8. If you add them, that is equal to 20. So that is how you use the triangle proportionality theorem. Another theorem that we will be discussing, or I will be discussing, is the right triangle similarity theorem. So what is right triangle similarity theorem? The right triangle similarity theorem states that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So we have here the illustration. We have here our original triangle as triangle IPK. So what is an altitude? An altitude is the height of a certain triangle. Now, if you draw an altitude or a segment representing the altitude or the height of a certain triangle, then you will be forming another two triangles. And those triangles are proportion or are similar rather to the original triangle and also similar to each other. So say for example, we have here our triangle IPK. So this is the original triangle. So we will be drawing an altitude. So we say we have here your PN. So this is the height or the altitude of our triangle. Now notice that after drawing this altitude, we have formed another two triangles. So aside from the original triangle, we have here your original triangle, your triangle IPK, and then we have formed another two triangles, namely your triangle PNK and your triangle INP. So there are three triangles now that is formed or that are formed after we have drawn the altitude of our original triangle. And basing or based on our right triangle similarity theorem, it states that these two triangles are similar to our original triangle and also similar to each other. So we can say that if PN is the altitude of triangle IPK, then IPK, which is the original triangle, is similar to triangle PNK, and also similar to triangle INP. Aside from the right triangle similarity theorem, we also have special properties of right triangles after drawing an altitude to it. So when the altitude is drawn to the hypotenuse of right triangle, first, the length of the altitude is the geometric mean between the segment of the hypotenuse. Second, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Now, what does it mean if we say geometric mean? Geometric mean is just the square root of a product of two quantities. So we will be using that one in solving for the missing segments or missing sides of our right triangle. Now, say for example, we have here our right triangle. So I have labeled here the different segments found in this right triangle. So we have here your A for one side of the triangle, B for the other side, and this C is the hypotenuse. Now, we have drawn an altitude here. So that is why we have different segments aside from the size of our triangle. So we have here segment E and segment F as the two segments formed within our hypotenuse, and then D as our altitude. Now, first one, we have here, the length of the altitude is the geometric mean between the segments of the hypotenuse. This is the length of the altitude. Now, in order for us to get the segment or the length of this altitude, then we are going to get the square root of E and F. E and F here are the two segments formed after drawing an altitude to your triangle, and this altitude is actually dividing our hypotenuse into two segments. Now, if you are going to get the measurement or the length of this altitude, then you need to get the square root of the product of these two segments here. So that is what we mean by geometric mean. So it is the square root of the product of E and F. And this E and F are the segments formed after your altitude is drawn from your right triangle going to the opposite side, which is your hypotenuse. And then each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So we are going to find for the two sides of our triangle. Now, in order for us to get the value of A, then A again here is the geometric mean because it was said here that each leg. So A here is the leg or is one leg of our right triangle here. So in order for us to get the value of A, we need to get the square root of C and E or the product of C and E. C here is the hypotenuse because each leg is the geometric mean between the hypotenuse, and that is C, and the segment of the hypotenuse that is adjacent to the leg. So this is the segment of the hypotenuse that is adjacent to A. So this is your A. So the segment adjacent to it is E. So therefore, if we want to get the value of A, we need to get the square root of the product of the hypotenuse and the segment. And that is C times E. So again, geometric mean, square root of the product of two quantities or two or more quantities. But in this case, we will be dealing with two quantities lang because we will have the segment and the hypotenuse. And then, for us to get the B, or in order for us to get the other value of the leg, then that will still be equal to the square root of the hypotenuse and the segment adjacent to our leg. So, the segment adjacent to our leg is F. So, therefore, in order for us to get the value of B, then we need to get the square root of the product of the hypotenuse, which is C, and the segment, which is F. So that is the special properties of right triangles. We will be applying this one on our next examples. Now here is an example. So solve for the unknown sides of the similar triangles. So we have here our illustration. We have here your triangle ARY, or we can say RAY because we will have the right triangle or the right angle here, which is A. So that is triangle RAY. Then we have here the altitude AM. Now, we need to get the measure of our altitude t. Again, based on the special properties of our right triangle, it was stated there that our altitude is the geometric mean between the segments formed on the hypotenuse. And these two segments will be your RM and then your MY. So T is the geometric mean between RM and MY. And geometric means we need to get the square root of the product of the measurements of these two segments. So T here would be equal to square root of my times Rm. So this is your my, this is your Rm, or Rm times my, because we can use your commutative property or commutative property of equality. So square root of my times Rm. T is now equal to my is equal to 16, and then Rm is equal to 9, so that is square root of 16 times 9. 16 times 9 is equal to 144. So our t is equal to square root of 144. Remember, we will be getting only the principal square root of 144. So we will be getting the positive value for this square root. So square root of 144 is equal to 12. So therefore, t is equal to 12. The altitude of this triangle is equal to 12. Next one, we will be getting the other leg or the one leg of our triangle. So that is shorter leg B. So we will be getting the measure of this leg here, leg B, or your segment RA or AR. So again, using the special properties of our right triangle, this leg here is the geometric mean between the hypotenuse of our bigger triangle or original triangle and the segment adjacent to our leg. So the segment adjacent to our leg is RM. So B will be equal to the square root of the hypotenuse, which is RY, and the segment adjacent to it, which is RM. So B is equal to square root of RY times RM. So B is equal to 25 times 9. So remember, this is RY, the hypotenuse, and that is 9 plus 16. So that is why we have here 25. And then the segment adjacent to B is RM, and that measures 9. So we have 25 times 9. 25 times 9 is equal to 225. So in order for us to get the value of B, we need to get the square root or the principal square root of 225. And the principal square root of 225 is 15. So therefore, B here, or the shorter leg of our triangle, is equal to 15. And then we will be getting as well the length of the other leg, which is our S, or the side S, or the segment AY or YA. Now, this segment AY here, or this S here, is the geometric mean between the hypotenuse of our original triangle and the segment adjacent to it. And the segment adjacent to S is MY. So therefore, it is, or we will be using this one in order for us to get the value of S. So S then is equal to square root of RY, which is the hypotenuse, times MY, which is the segment adjacent to S. So S is equal to square root of RY times MY. Now S is equal to 25 times 16. 25 is the hypotenuse, 16 is the adjacent segment. So we have 25 times 16, that is equal to 400. So square root of 400, or principal square root of 400, is equal to 20. So S is equal to 20. So therefore, the longer leg S for our triangle is equal to 20. So these are the measurements of the sides of our given triangle. So you can always use the properties of special triangle in order to solve for the measurement of each side of this triangle, or of our triangle. Okay? We are now down to the last topic of our lesson. So we will have the special right triangle theorem. So there are two special right triangles. We have the 30, 60, 90, and also the 45, 45, 90, which is also called the isosceles right triangle. So we will be dealing with those two triangles. So let us have the first special right triangle. We have the 45, 45, 90 triangle, or the isosceles right triangle. So in a 45, 45, 90 degree triangle or isosceles right triangle, the hypotenuse is square root of 2 times the length of the leg, and each leg is square root of 2 divided by 2 times the hypotenuse. Now, why is 45, 45, 90 degree triangle called isosceles triangle? Now, obviously because these two angles here are congruent. So the opposite sides of these two angles will also be congruent to each other or equal to each other. So therefore, this triangle will have two sides which are congruent, and therefore it is called an isosceles triangle. Now, this is a special triangle since we have these properties as well. First, the hypotenuse in this triangle is equal to square root of 2 times the length of the leg. So this is also somewhat like a formula. In order for us to get the hypotenuse, we will be multiplying the length of the leg by square root of 2. Remember here, the two legs of our triangle are congruent. So if this is one leg, this will be equal to the other leg because this is a 45, 45, 90 degree triangle. So this angle here is congruent to this angle, and those opposite sides or these opposite sides will also be congruent to each other. So whatever is the measure of this side will be the measure of this side as well. Okay? Now, if given the value of one leg of this triangle, then to get the other side, that will be equal. So, if this is 5, this is also 5 because they are just equal. And for you to get the hypotenuse, you just have to multiply the leg by square root of 2. So, if the measure of one leg is x, then the other leg would be x. And the measure of the hypotenuse will be equal to the product of x and square root of 2. So, say for example, this leg is 4. So, this is 4. And this leg is also 4. And our hypotenuse will be 4 square root of 2 because we multiplied 4 by square root of 2. So, that is how you get the hypotenuse in a 45, 45, 90 degree triangle given the length of the leg. Now, if given the hypotenuse, then each leg is square root of 2 divided by 2 times the hypotenuse. So, this is the other formula. So, if given naman ang hypotenuse, then all you have to do is to multiply your hypotenuse by square root of 2 divided by 2 in order for us to get the two legs. So, say for example, given the hypotenuse is x square root of 2. So you need to multiply this one by square root of 2 divided by 2. And that will be equal to x times square root of 2 times square root of 2 divided by 2. So square root of 2 times square root of 2 is square root of 4, and that is equal to 2 divided by 2. So there will be a cancellation in the 2. So what is left is x. So that is why each leg is equal to x. So again, our formula, hypotenuse is equal to square root of 2 times the leg. And the leg is equal to square root of 2 divided by 2 times the hypotenuse. Now, let us have an example. Now, applying the formula, the following relationships can be established. So, we have here again the formula. Leg is equal to square root of 2 times the hypotenuse. So, if this is in the case wherein the hypotenuse is given and you need to look for the value of leg. And then this one, given the leg, you need to get the hypotenuse. So, the formula for that is hypotenuse is equal to square root of 2 times the leg. Now, example, if the hypotenuse is equal to 5, then the leg is 5 times square root of 2 divided by 2. Because again, given ang hypotenuse. So, to get the value of the leg, you need to multiply the hypotenuse by square root of 2 divided by 2. So, 5 times square root of 2 divided by 2 is 5 square root of 2 divided by 2. So, this is now the leg. Now, what if given ang leg? So, if the leg is equal to 12, again, to get the value of the hypotenuse, we need to multiply the leg by square root of 2. So the leg is 12. So we need to multiply this one by square root of 2. So that is equal to 12 square root of 2. Okay? So, leg to hypotenuse, you need to multiply the hypotenuse by square root of 2 divided by 2. Hypotenuse to leg, you need to multiply the leg by square root of 2. Understand? So, that is for your 45, 45, 90-degree triangle or isosceles right triangle. So, the key term there is square root of 2 actually. It's just multiplying the given by square root of 2 or dividing the given by square root of 2. So, it depends. Let us have the other special right triangle, the 30, 60, 90 triangle. So, in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. Or the length of the longer leg is square root of 3 times the length of the shorter leg. So these are the formulas if given the shorter leg. Now, how about if we are to look for the shorter leg? So the length of the shorter leg is 1/2 the length of the hypotenuse, or the length of the shorter leg is square root of 3 over 3 times the longer leg. Now, be sure with the location of each angle in your triangle. Unlike the 45, 45, 90-degree triangle, wherein if this is your right angle, these two angles here will surely be 45 and 45. Here, you need to be sure of the positions or of the location of our angles. But just always remember that the opposite of our 30-degree angle is always the shorter leg. The opposite of the 60-degree angle is our longer leg. And the opposite of our right angle will always be the hypotenuse. So, if in any case, your 30-degree angle is here, then that means to say this side here is the shorter leg. And if 60-degree angle is here, then of course this will be the longer leg. So always be sure or be assured of the locations of your angles. Now, let us proceed with the length of our hypotenuse. So, given the shorter leg, to get the length of the hypotenuse, all we have to do is to multiply the shorter leg by 2. So, the hypotenuse is just twice the leg. So, if the shorter leg, if the shorter leg is 5, of course, the hypotenuse is equal to 10. And likewise, if your hypotenuse is equal to 20, then the shorter leg is equal to 10. That would be half the hypotenuse. So again, hypotenuse to shorter leg, we need to divide by 2. Shorter leg to hypotenuse, we need to multiply by 2. And then, for the length of the longer leg is square root of 3 times the shorter leg. So, given the shorter leg, we need to multiply the shorter leg with the square root of 3 to get the length of the longer leg. So, if your shorter leg is equal to 5, then the longer leg will be 5 square root of 3. Or, if given ang longer leg, then you need to divide the longer leg by square root of 3 to get the value of the shorter leg. Or you can simply multiply the longer leg by square root of 3 divided by 3 because there will be a rationalization on the final answer if we will be dividing any length of our longer leg by square root of 3. So, para sure na lang, you can multiply your longer leg by square root of 3 divided by 3. So, say for example, we have here your triangle. Rapabidya si 2x and then x square root of 3. Now, given the shorter leg, again, to get the hypotenuse, we need to multiply the shorter leg by 2, or that is twice the shorter leg. So, if your shorter leg is x, we need to multiply this x by 2 to get the hypotenuse. So, x times 2, that is 2x. So, your hypotenuse is equal to 2x. And then, given the shorter leg, we need to multiply the shorter leg by square root of 3 to get the longer leg. So, if your shorter leg is x, then multiplying it by square root of 3, we will have x square root of 3 as the longer leg. Now, let us have some examples. Applying the formula, the following relationships can be established. So these are the formulas. Again, shorter leg is equal to half the hypotenuse, or shorter leg is equal to square root of 3 over 3 times the longer leg. Or if you want to get the longer leg, that will be equal to square root of 3 times the shorter leg. Or if you want to get the hypotenuse, that is twice the shorter leg. Now here, given the shorter leg, if the shorter leg is equal to 6, what will be the values of the longer leg and the hypotenuse? So shorter leg to longer leg. Again, if given the shorter leg, to get the longer leg, we need to multiply the shorter leg by square root of 3. So 6 times square root of 3 is 6 square root of 3. So that is the longer leg. Given the shorter leg, to get the value of the hypotenuse, we need to multiply the shorter leg by 2. So 6 times 2, hypotenuse is equal to 12. Okay? So shorter leg to longer leg, multiply by square root of 3. Shorter leg to hypotenuse, multiply by 2. Now, how about if given the hypotenuse? Now, given the hypotenuse, we don't have here the direct relationship between the hypotenuse and the longer leg. So, pwede kita mag-aganize sa shorter leg before we can reach the longer leg. So, hypotenuse is equal to 10. So, remember, shorter leg is equal to half the hypotenuse. So, if the hypotenuse is 10, we need to divide this one by 2 to get the shorter leg. So, 10 divided by 2, that is equal to 5. So, shorter leg is 5. Now, since we have solved for the value of the S, or the shorter leg, we can now get the longer leg. So, remember, shorter leg, the longer leg, that is shorter leg times square root of 3. So, shorter leg is 5 times square root of 3. So, our longer leg is 5 times square root of 3. Okay? And then last one, if longer leg is equal to 7 times square root of 3. So, longer leg to hypotenuse, we don't have the direct relationship. But longer leg to shorter leg, we have. So, if we want to solve for the shorter leg, given the longer leg, that is square root of 3 times or divided by 3. So, we need to multiply this 7 times square root of 3 by square root of 3 divided by 3. So, square root of 3 divided by 3, which is the formula, times the longer leg, which is 7 times square root of 3. Okay, so 7 times square root of 3 times square root of 3. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is equal to 3. So that is 7 times 3. So that is 21. Divided by 3. So the answer is 7. So the shorter leg is equal to 7 if the longer leg is 7 times square root of 3. And then for the hypotenuse, since we have solved for the value of S already, so again, hypotenuse is equal to twice the shorter leg. So 7 times 2, that is equal to 14. So our hypotenuse is equal to 14. Okay? Now let us have more examples on this one. Now let us have some examples. So we need to fill in the blanks with the measures of the unknown sides. So let us have first the 30, 60, 90 degree triangle. So again, your shorter leg is equal to 1/2 the hypotenuse, or your hypotenuse is equal to twice the shorter leg. And your longer leg is equal to the shorter leg times square root of 3. Now, let us have this one first. Given the shorter leg. So, shorter leg is equal to 8. So, first, we need to get for the longer leg, or the value of the longer leg. So, again, given the shorter leg, longer leg is equal to shorter leg times square root of 3. So, 8 times square root of 3, longer leg then is 8 times square root of 3, or 8 square root of 3. Next one, given shorter leg, if we want to get the value of the hypotenuse, then we need to multiply our shorter leg by 2. So 2 times 8, that is equal to 16. So therefore, hypotenuse is equal to 16. Next, given the hypotenuse. Hypotenuse is equal to 12. So shorter leg. So given the hypotenuse, we need to divide this 12 by 2 to get the shorter leg. So 12 divided by 2 is equal to 6. So shorter leg then is equal to 6. And then given the shorter leg, we need to get the longer leg. So shorter leg again times square root of 3 will be equal to the longer leg. So 6 times square root of 3, longer leg now is equal to 6 times square root of 3. And then last one, we have the longer leg. The longer leg is 9 times square root of 3 or 9 square root of 3. So to get the shorter leg, we need to multiply this one by square root of 3 divided by 3. So 9 times square root of 3 times, or 9 square root of 3 times square root of 3 divided by 3. So square root of 3 times square root of 3 is square root of 9, and that is equal to 3. Multiply it to 9, that is 27, divided by 3. So we will have shorter leg is equal to 9. And hypotenuse is equal to twice the shorter leg. Shorter leg is equal to 9. So therefore, hypotenuse is equal to 18. So that is how we get the different parts of our right triangle if we are dealing with the 30, 60, 90 triangle. And then we also have the 45, 45, 90 degree triangle or the isosceles right triangle. Now, hypotenuse is equal to 9. So again, hypotenuse, the leg. So we need to multiply by square root of 2 over 2 or divided by 2. So 9 times square root of 2 over 2 is equal to 9 square root of 2 over 2 or divided by 2. So this is hypotenuse to leg. Now, how about leg to hypotenuse? So, in order for us to get the hypotenuse, we need to multiply the leg by square root of 2. So, 5 times square root of 2, hypotenuse is 5 square root of 2. And then, going back to the hypotenuse, again, hypotenuse to leg. So, that is equal to hypotenuse multiplied to square root of 2 divided by 2 to get the leg. So 14 times square root of 2 divided by 2, that is 4. 14 square root of 2 divided by 2. So 14 divided by 2, that is 7. So leg is equal to 7 times square root of 2. So that is how you get the different sides or legs or hypotenuse of our triangle given that we have the special right triangles. So that is all for this video tutorial. Thank you for watching and for listening, and I do hope that you have learned something from this video. So if you have any questions or clarifications, feel free to message us through our FB accounts or text us through the numbers that were given to you by your advisors. So from me, Tata, and Squirtle, stay safe and healthy always, mga palangga. Bye!